So pada screen STATA ni saya akan buka dataset tadi tu, open. Nampak saya ada banyak file DTA ni. DTA adalah untuk STATA DTA adalah untuk STATA. How to STATA. Alright. Saya buka file ni, how to STATA. Okay. Jadi bagi tujuan hari ni, biasalah kan, kita nak belajar benda yang baru, kita kena ambil benda yang lama dulu. So benda yang lama yang saya buat dengan you all dulu adalah data SGA. Jadi saya gunakan data SGA anda. Okay. So arahan pertama senang je. Nak create variable baru. Jadi kita akan create variable baru ni gunakan STATA. Okay. Okay, jom kita pergi balik ke STATA. Jadi sekarang ni kita akan create dataset yang baru. Jadi sekarang ni kita nak create data baru. Kita nak create new variable. So first kita akan create variable. Apa nama kita buat? Kita nak buat BMI. So type BMI. Create, specify a value or expression. Klik butang create. So kita dapat expression builder. So kat mana shape variable? Kat sini. So ni weight. Masukkan ke atas. Double click. Weight divide by height. So height tu dalam bracket. Kita ambil height. Okay, double click. Dia naik ke atas. Bagi 100. So bagi dengan 100. Okay. Lepas tu kita kena kuasa duakan yang height ni. Saya klik OK. Dia akan create variable baru. Jadi sekarang ni kalau apa saya buat, saya klik pada data. Data editor browse. Saya nampak ada variable baru, itu BMI. Okay, next. Next we are going to generate a new variable, the mean, standard deviation. Okay. The mean and standard deviation. So to do that, we are going to use summary statistics. So please follow me. I'm going to show this step by step. So describe data, summary statistic. I'm going to show you my STATA screen. Okay, this is my STATA screen. Okay, so I'm going to click on data, describe data, summary statistics. So what do you want to describe? I want to describe for BMI. So I just click here, pull down. I select the BMI. Okay, you can put in all the variables if you want to. Okay, you can put in all the variables you want to, but here I just want to display what I need, which is the BMI. Okay, if you look at the notes, okay, you can select exactly what you want to display. Here in this case, I just want the standard display, the mean mode, minimum, maximum. Okay, so I'm just going to click the command. So click here, data, describe data, summary statistics, BMI, standard display. I just click OK. Really, the answer came here. Okay. This is another reason why STATA is not so good. Why? Because they give you the display like this as a text file. And this text file, the graphic is not so nice. Okay. So what to do? The only way we can do this is copy like this. Copy. Then you paste it into your diagram. So if you copy this inside your Word or PowerPoint, they come out like a text file. So it is not that good. Okay, notepad. Why notepad? Because this is a text file. So it looks like this. The output of the analysis looks like this. Horrible. Okay, not so good. Okay, so I'm going to go next. Next, I'm going to go to the next slide, which is the tougher one. Okay. Okay, right now we are going to create a new variable, and this new variable is entitled obese class. So we're going to use the following cutoff point. less than 20, 20 to 24.99, 25 or larger. So for the below 20, it is underweight. 20 to 24.99 as for normal weight. 25 or larger is overweight. I'm going to show you the command line by line so that you see what happened. Okay. So here's the command window. Click the command, enter. Okay. So you see here, when we type this one, generate obvious class equal to 1, automatic when you browse the data set. Okay. So the data set, where it is the data set? Data set. So you can see here, all those that is below than 20, they give the value of 1. All those without any value, they don't give any value. Okay, it is missing value. So out of 100 of this data set, only 20 got value, the other 80 is missing value. Okay, so that is the first round. So second round, I'm going to type in the command. Okay, this command, Doktor tak type pun, yeah, I can copy and paste. What should I type? Okay, so I'm going to go next page. This page. I'm going to type the second line of command. Okay, so we have other values, BMI more than 20, but less than 25. That one I want to code as 2. So you can see here, they type in 48 real changes made. So the 48 real changes made, if you look here inside your STATA, okay. Doctor, what the hell are you doing? I'm moving my screen. So you can see here on the left side, okay, on the left side, okay, I just move it to the center. All those between 20 to 25 are given the value of 2. So weird, Weird. So this is how STATA works. They do step by step. They don't do immediately everything. Okay, so that's the second part. So now we're going to do the third part. So the third part is now we're going to create the variable anything larger than 25 as obvious class 3. So copy this command. Okay, this is the part. We're going to type the command. Okay. So you can see here, finally we got all the value already. 1, 2, and 3. There is no more missing value. Everything has been given the value of 1, 2, or 3. Okay. 1, 2, and 3. Okay. So now we're going to label the obese class variable as classification of obesity. We're going to label the command as classification of obesity. Okay, this one I may have to retype because label variable obese class, you get this single bracket, cannot, must use double bracket. So I'm going to use double bracket. Okay. So you can see here now, it works, but now because the copy and paste was from PDF, it did not work. It did not work. Okay, since we know the problem is with the label, we are going to retype all the command after the tab. Okay, so here I'm going to paste. Okay, so you see that slash, I'm going to change become bracket, so double quotation mark. Again, this one, okay. 2, I'm going to put as what? I'm going to put as normal. The way they code is different than what we are used to inside SPSS. So define obese class, 1 as underweight, 2 as normal, 3 as overweight. Okay, so similarly we got these 3 labels. Okay, we already defined. Now we're going to put in the values. So label value obese class as obese class. Okay, so alternate tab. So I'm going to type in the command here, label values obese class as obese. So you can see here, just now we already clicked this now, don't have, kan? But the minute I press enter here, all the values are entered already. Okay, we're going to tabulate a new table. So the tabulate is like cross tabulation command. It is like the cross tabulation command. Okay, so command Control V, tabulate missing class. Yay, we got it. Now we're going to do the chi-square. So for the chi-square, we are going to do against between obvious class and the outcome. The command is the same. The command is the same. The command tabulate. So it is under summaries, tables and tests, frequency tables, two-way tables with measures of association. Okay. So let's go and do STATA next one, which is two-way table with measures of association. So this one is chi-square. Alright, click statistics, summaries, tables, and tests. So what we want to do, we want chi-square. So we want two-way frequency tables, two-way table with measures of association. What is the row? The row is for obvious class. What is the outcome? The outcome is for SGA. What do you want? I want Pearson chi-square. I click Pearson chi-square. Okay. So what is your contents? So you got two kinds of, we got column percent, we got row percent. I want the row percent. Click OK. Ah, see? So this is the chi-square. Next, I'm going to show you how to do the students t-test. So what we're going to compare, we're going to compare the BMI between the two groups, those with SGA and those without SGA. So for the command, it is a classical test of hypothesis, mean comparison test. So how to do it? Statistics, test, classical test of hypothesis, t-test. Okay, so you got two groups. Okay, so we are going to have two groups. The variable name here is BMI. The group name is outcome. Okay, then they ask us, are the variance equal or unequal? Ayo, you calculate lah, why you ask me? But what to do, they ask. So we can click here on unequal variances. If you think your variances are not equal, I'm not going to bother, I'm just going to click OK. So immediately they give two sample t-test with equal variances. So doctor, how do you know it's equal or not? Look at the standard deviation. 4.6 squared. 25 versus 16. Okay. Not double. So we are okay. Okay. So you get the variance of these two values and see whether they are double or not. If it is not double, variances are equal. Variance is the square of standard deviation. So you can see here, they give you the t value of 3.7748. 3.77, it is already more than 1.96. Since it is already more than 1.96, we are okay. Okay, we are okay. So they are significantly different. So which one is higher? Those with the normal group has got higher mean of BMI, or with 25, and SGA is 22. Okay, so that is how it is done. Okay, so you can see there's an explanation. So you got the t value is significant. Okay, so that is how we do a t-test. Okay, so now we're going to the next one. Okay, the next one is for Anova. Okay, so we're going to do Anova. So for Anova, under STATA, they also got Anova. So the Anova is under linear models and related, Anova and Manova. So you select one-way Anova. Statistics, linear models, Anova and Manova. So what is the response? So in this scenario, the question is, whether the birth weight is affected by the weight classes. Okay, so the outcome we trace out is birth weight. So the outcome is birth weight. Okay, birth weight. What is the factor variable? The factor variable is obese class. Okay, so what the test you want to use? You can use Bonferroni, you can use Chef, you can use SIDA. So for us, we are used to Bonferroni. Okay. So we're going to select summary table and all the other results. Okay. So you're going to click that. Okay, select, 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 select. Okay, so click OK. Immediately we got the results. You can see here, this is the test. So underweight, the baby's weight is 2.3, normal it is 2.7, overweight is 3.11. So is it significant? Yes, it is significant. How do we know it's significant? Because you can see that the F is 14.72. The probability is less than 0.0000. Okay. Okay. So let's go next one. Anova, we got extension. Okay. So what are correlation as standard as before? That what we did. We're going to do correlation for BMI and birth weight. What is the risk factor? The BMI. What is the outcome? Birth weight. So we're going to do the appropriate statistical test to prove association. Because we want to prove association, we do correlation. Okay. So demonstrate the association using the appropriate chart. Determine the coefficient of determination. Okay. Okay. So we're going to do correlation. Statistic summary. Okay. Okay, so you can see there correlation and covariances. Okay. So what are we going to do? We're going to do between. Okay. Which variable to select? You just select on the left side. Which one for come first? Risk factor come first. So here it is the mother's BMI. Okay. Then it is the outcome. The outcome is birth weight. Okay. So you can see it like that. Click OK. So you can see the correlation. It is 0.4865. Okay. So now we're going to create a simple linear regression. To create simple linear regression, we're going to use the command linear models and related. We're going to use the command linear models and related. So click statistics, linear models and related, linear regression. Okay, what is the dependent variable? The dependent variable is the outcome, which is birth weight. What is the independent variable? In this case, it is the mother's BMI. Okay. You click OK, you get the result. So y equals a plus bx. Y equals a plus bx. So y equals to 1.337 plus b is 0.06 BMI. Okay, so that is the answer here. So the answer is only from this table. Is it significant? Yes. The p-value are all very significant. Okay, r square is 0.2367. Adjusted r square is 0.2289. Because this one is single, so we take the r square 0.2367. So 24% of the baby's birth weight is determined by the mother's BMI. So this is a formula. So 1.337395 plus 0.06 BMI. So now we're going to do the last part, and the last part is to do scatter diagram. So to do the scatter diagram, graphic scatter Okay. Plot. Scatter plot. Accept. Okay. What is your y? Your y is the outcome. The outcome is birth weight. What is your x? Your x is the risk factor, which is the BMI. Next. Okay. You accept. Click OK. And you get it. You're so slow. Calling London, calling London. Okay. So now the scatter diagram is there. The scatter diagram sucks. Why it sucks? It does not start at 0. It does not start at 0. Okay, you're supposed to edit the graph and adjust it accordingly so that it fits. Okay, so right now I'm going to start the scale. Okay, extend the range of axis scale. I'm going to start from 0. Apply. Start from 0. Next. Okay, so you can see here, I want to edit this one, so I double click. Okay, scale. Start from 0. Okay. Okay, so we have this one.